Good day everyone! So for today's video, we will be talking about the linear programming problems. There will be two problems for us to answer and to discuss.
I'm GELSANO reporting the given problem number 1. So the given linear problem is to maximize 2 equals 5x plus 8y is the objective function. Then 2x plus y less than or equal to 14 and x plus 3y less than or equal to 17 are the structural constraint. X and y greater than or equal to 0 is the non-negativity constraint. To solve this, may I call on to the next reporter.
Good day everyone, I am ALDWIN TEJAS. I'll be discussing or reporting the substitution to get the ordered pair. So let's start. Let x equals 0. The given is 2x plus y is equals 14. So now, let's do the solve. 2, open parenthesis 0, close parenthesis, plus y is equals 14. Y is equals to 14. Open parenthesis 0, comma, 14, close parenthesis, is the ordered pair. And that is the answer of the problem number 1. Let y equals 0. 2x plus 0 equals 14. And the cancellation is 3x over 2 equals 14 over 2. The answer is x equals 7. And this is the right to do when you write your answer. Open parenthesis 7, comma 0, close parenthesis is the ordered pair of the problem 2. And let's go to problem 3. X plus 3y is equals 17. Let x equals 0. 0 plus 3y is equals 17. 3y is over 3 is equals to 17 over 3. And the answer is y is equals 17 over 3. And the proper answer is open parenthesis 0, comma 17 over 3, close parenthesis, or there is another way to write your answer. Open parenthesis 0 0, comma plus 5.67, close parenthesis, is the ordered pair. And the next problem is let y equals 0. X plus 3, open parenthesis, 0, close parenthesis, is equals 17. So x plus 0 equals 17, x is equals to 17. Open parenthesis 17, comma 0, close parenthesis is the ordered pair. And that's all. Thank you of my report.
Good day everyone, I am Kent A. PERIJAN and I would like to thank Mr. ALDWIN TEJAS for providing us the correct data to make and plot our graph that we will use to connect the x and y axis. So let's plot the data. 0 and 14 and 7 and 0, and let's connect to the x and y axis. And the next is 0 and 5.67 and 17 and 0, and let's connect the x and y axis. And we're finished connecting to the x and y axis, and let me call on Mr. MONDOñEDO to continue the report.
So good day everyone, I'm MONDOñEDO Jr. and now next is we need to identify if the shading is above or below the line. Our symbol is less than or equal to 50, so we need to use a solid line. So the shading here is below the line because x and y is less than equal.
So next, we can see in the graph that the shading is below the line. So we can now identify our fishable region. So they meet on the corner point on the points of 0, 0, 0, 5.67, 7, 0, and 5, 4. So inside this area is what we call the feasible region. So all the value present in this area are all set of possible feasible solution. So next.
Now we are down to our last step, which is to solve for our corner points. We have there our 4 different corner points vertices and our objective function, which is maximum of z is equals to 5x plus 8y. To solve for our corner points vertices, we need to substitute it in our objective function. For our first vertices, we have there x is equals to 0 and y is equals to 0. Let us substitute in our objective function. Z is equals to 5 times 0 plus 8 times 0 is equals to 0. For second corner points vertices, we have there 0 for the x and 5.67 for the y. So z is equals to 5 times 0 plus 8 times 5.67 is equals to 45.36. For our third corner points vertices, we have the x is equals to 7 and y is equals to 0. So z is equals to 5 times 7 plus 8 times 0 is equals to 35. For our last corner points vertices, we have there x is equals to 5 and y is equals to 4. So z is equals to 5 times 4 equals 25 plus 8 times 4 is equals to 32. So 25 plus 32 is equals to 57. Since the problem is looking for the maximum value, as you can see in the table, the solution set of this LP model is x is equals to 5, y is equals to 4, and z is equals to 57.
For the problem, a veterinarian mixes 2 types of animal food, X and Y. Each unit of X costs 100 pesos and contains 40 grams of fat, 20 grams of protein, and 1,600 calories. Each unit of Y costs 80 pesos and contains 60 grams of fat, 60 grams of protein, and 1,200 calories. Suppose the veterinarian wants each unit of the final product to yield at least 380 grams of fat, at least 240 grams of protein, and at least 9,600 calories. How many of each type of grain should the producer use to minimize his cost? So first, we will be making a table, like what you have seen on the screen, so it is much easier to identify what is given and easy to know what are we finding or what are we going to do to solve this problem. For the first row, we have the grain X and grain Y, as for the given and the requirement for each grain to have. For the first column, we also have here the fats, protein, calories, and cost, which is given in the problem to show how much gram of each grain should contain. For the fats, grain X contains 40 grams while grain Y contains of 60 grams. For the protein, grain X contains 20 grams and grain Y contains 60 grams. For calories, grain X and Y contains 1,600 and 1,200 calories respectively. For the cost, grain X costs 100 pesos and grain Y costs 80 pesos. The required fat must be at least 380 grams, protein must be at least 240 grams, and calories must be at least 9,600. So how many grain X and how many grain Y must the producer use to achieve the requirements with the least cost? So to know the answer, just keep on watching as my co-students will explain.
Thank you, Ms. Roa. For the second problem, the objective function is to minimize the cost equals to 100x plus 80y, and its constructual constraints are 40x plus 60y less than equal to 380. Second is 20x plus 20y less than equal to 240. Third is 1600x plus to 1300y less than equals to 9600. And lastly, xy less than to 0. To know the answer, just keep on watching as my co-student will explain.
So now, let's move on. So next, we will need to get our ordered pair by converting our symbol which is greater than or equal to. So instead of that, we will use an equal sign, and also by letting x equals to 0 and y equals to 0. So our first ordered pair from 40x plus 60y equals 380, and letting x and y be a 0, so we now have an ordered pair of 0, 6.3, and 1950. 20x plus 60y equals 240. Substitute x and y to 0. Our second ordered pair is 0, 4, 12, 0. And lastly, 1600x plus 1200y equals 9600. Let x and y be a 0, so our last ordered pair is 0, 8, and 6, 0.
Everyone, I'm ADRIAN SUICO, and I would like to thank Ms. DINGLASA first for providing us the sufficient data to make it possible to make and plot our graph. Now, we will use that data to construct the graph and connect our y and x axis. First, we have 0 and 6.33. Its plot should be here, and 9.5 and 0. And it's over here. We easily connect them together, our x and y axis. We will continue to do the same with the other given data, which are 12 and 0 and 0 and 4. You easily connect them and we're done. And for the last pair of data that we have 0 and 8 and 6 and 0. With that said, we're done with connecting our x to and our y axes. Now, may I have Mr. ABANSADO to continue with our report. Thank you.
I'm one of the members of the group 4. So now I will be discussing to you the visible region on the graph of our example number 2. But before I'll go ahead and discuss the graph, I'll go ahead and define first what is visible region. So visible region in a linear program is the set of all possible visible solutions. So basically, all the numbers that is covered or part of the visible region can be used to solve the equation, and the result will be positive or will be true. So let's go back to the graph of our example number 2. So as you can see here, the visible region is above, or the shaded part of the 2 and 0, 7 and 2, 2 and 5, and 0 and 8. So basically, those are the region where all the numbers covered can be used to solve the equation, and the answer will be true. So how would you determine if all these numbers or all these how would you know if the graph, or how would you know the region from the graph is a visible region? So it is the region where all of the line graphs met, and it means that this region is visible. And based on this example number 2, you can see this is an example of unbounded visible region because there's no boundaries. So that means that the numbers above 12, 7, and 2 and 5, above the numbers can be used to solve the equation. So
since we already have our visible region, we will test its vertices to determine the optimal solution, which we will substitute our corner points to its objective function, such as substituting 0, 8 to its objective function, which is minimum cost equals 100x plus 80y. Now we have c equals 100 times 0 plus 80 times 8 is equals to 640. Corner points of 2, 5 substitute to its objective function, we have the equal of 640. 7, 2 substitute to its objective function, we have 1200. Since we are looking for the minimum cost, so our solution to this LP model is x equals 2, y equals 5, and z equals 600.